Imagine falling toward a place where every law of reality begins to break. Not because it's hot, not because it's dark, but because time itself may never let you leave. From the outside, you'd appear frozen forever. But for you, everything would keep moving. Every second pulls you closer to something no human has ever seen. The event horizon. The point where escape becomes impossible. Cross it once, and the universe you once knew is gone forever. Scientists call this invisible boundary the event horizon. It isn't a wall or a surface you can touch. It's simply the point where gravity becomes so powerful that even light cannot escape. If light cannot escape, neither can any message you send back to the outside universe. To a distant observer, your movements would grow slower and slower. Your heartbeat, your breathing, even blinking would seem to almost stop. Eventually, you'd appear completely frozen in time. But that's only an illusion created by extreme gravity. For you, nothing unusual happens as you cross. No explosion, no flash of light, no invisible force pushing you back. Once inside, there's only one possible future. Every path, no matter which direction you choose, leads deeper into the black hole. Falling toward the center becomes as unavoidable as moving into tomorrow. Even firing your engines only delays the inevitable. Escape no longer exists. The universe still looks beautiful, but its laws have completely changed. Ahead lies one of Einstein's strangest predictions. As you fall deeper, gravity no longer pulls equally on your body. Your feet are slightly closer to the center than your head. That tiny difference changes everything. At first, you wouldn't notice, but every second, the difference grows stronger. Scientists call these tidal forces. They stretch objects in one direction and squeeze them from the sides. This bizarre process is called spaghettification. But here's the twist. Not every black hole would stretch you as you cross the event horizon. The biggest black holes are surprisingly gentle at first. Their gravity is stronger overall. But the difference across your body is much smaller near the event horizon. You could cross without feeling anything unusual. You wouldn't know the point of no return was already behind you. The universe would still appear above you, while every possible future carried you deeper toward the center. That's when reality becomes stranger than almost anyone imagines. Inside the event horizon, your eyes would still work. Space wouldn't suddenly turn black. Instead, the universe outside could appear more distorted than ever. Light from distant galaxies would bend in impossible ways. Some stars might even appear where they shouldn't. The universe would seem to fold around your view. Every direction would become less familiar. The deeper you fell, the stranger everything became. Even the idea of straight ahead would lose its meaning, as space itself curved around you. But this was only the beginning. The strangest part wasn't gravity. It was time. For you, your watch would tick normally. Your heartbeat would stay steady. Every breath would feel the same. Nothing about your own experience would suggest time had changed. But far outside the black hole, time could be passing very differently. Entire civilizations might rise and disappear while your journey continued. Stars could be born and die while you kept falling. The universe you left behind might no longer exist as you remembered it. And then, ahead lies the greatest mystery of all, the singularity. According to Einstein's equations, this is where space and time are predicted to break down. Distances lose their meaning. Time no longer behaves the way our universe taught us. Our understanding of reality reaches its limit. But here's the truth. Nobody knows what happens there. Our current laws of physics stop giving reliable answers. It remains one of the greatest unsolved problems in science. So what possibilities are scientists exploring? One idea suggests black holes may not be the end. Some physicists have wondered whether another universe could exist beyond them. Right now, there is no evidence for this. It remains only a fascinating hypothesis. Another possibility is even stranger, a theoretical object called a white hole. Instead of pulling everything inward, it would push everything outward, releasing matter and light back into the universe. But no one has ever observed one. Black holes hide yet another mystery. Imagine throwing a book into one. Every word inside contains information. So what happens to it? According to quantum physics, information should never truly disappear. But black holes seem to tell a different story. If information is destroyed, some of our greatest theories would be incomplete. If it survives, then the universe is protecting one of its deepest secrets. and we're still trying to understand how. Black holes may seem eternal, but they probably aren't. In 1974, Stephen Hawking proposed something extraordinary. Black holes could slowly lose energy through what we now call Hawking radiation. The process is unbelievably slow. Even a supermassive black hole could survive, far longer than the current age of the universe. But eventually, even giants run out of time. One day, the black hole would disappear completely, which brings us to the biggest question. What happens to everything that fell inside? That mystery has challenged physicists for decades. Some believe the information is preserved on the event horizon. Others think quantum gravity changes everything. The truth is, we simply don't know. No experiment has yet revealed the full answer. Scientists continue testing new ideas, searching for a theory that can unite gravity and quantum physics. Every discovery brings us closer, but every answer reveals another question. Maybe that's what makes the universe so extraordinary. Not because it gives us every answer, but because it never stops asking new questions. Our journey began with a single impossible destination. At first, it seemed like a dark object drifting through space. Gravity rewrote reality itself. Light bent, time slowed. The universe became more beautiful and more terrifying. We crossed a boundary from which nothing can return. Beyond that point, even science searches for answers. The deeper we explore, the more extraordinary reality becomes. A black hole may be one of the strangest objects in existence, yet it is only one small part of an unimaginably vast universe. Galaxies hide countless black holes. Some are sleeping, others feed with unimaginable power. Across the observable universe, countless mysteries remain. Every discovery opens the door to another question. That's how science moves forward, not by ending curiosity, but by inspiring the next question. We began with a single question. What happens after you cross a black hole's event horizon? We discovered that reality is stranger than imagination. Light bends, time stretches, space itself begins to lose the meaning we once gave it. And beyond all of that, the universe still refuses to reveal its final secret. Maybe one day, humanity will find the answer. Until then, every black hole remains an invitation to wonder, because beyond every horizon, another mystery is waiting.